Hey, what's up, my legions of 8.7 YouTube followers? This is Gibson GA-6 amplifier update number 7. The amp is now up and running and pretty much finished. The transformers having arrived for Mercury, and as we can see down here, mounted to the original speaker frame, which is, the speaker's been reconed. We have the clone of the GA-6 output transformer, and it was a direct bolt-in replacement. You'll recall in a previous episode we said that, I said that mounting the output transformer to the speaker doesn't meet modern safety standards because there's high voltage on one side of it. And if there was ever a, primary to core short, you could wind up with high voltage on the entire frame of the speaker. That's not a great thing if you stick your hand back there and you get a very unwelcome surprise. So to kind of bring things up to modern standards, I have added a fourth wire to the 3 wires coming down, that green ground wire, which is soldered into a terminal lug, which is mounted, screwed in along with the transformer to the frame of the speaker. I scraped away the varnish on the transformer before putting that lug on so it would get a nice metal to metal contact. So now that entire frame of that transformer is grounded. So if it ever did develop a primary to core short, we'd be protected from that, at least in theory. And to kind of cover up those 3 wires, red, brown, and blue, that have high voltage on them, on the order of 400 volts or so, I put an extra layer of shrink wrap there and kind of tucked the wire up around back to where it comes in here. And there we can see, if it will focus, we can see the big fat green ground wire coming in and going straight to the chassis, starred in with the 3rd prong ground and all of the center taps from the transformers and the main power supply ground, all of that starred in together right there. And again, scrape away the paint to the chassis to ensure good metal to metal contact. So that's that. The power transformer, also for Mercury, is hidden behind here. We can see all the wires coming in from it. We can see the twisted pair of red wires, which are the high voltage going to the rectifier. The yellow ones in the background there are the filament windings. And tied into one of the filament windings, we have the main high voltage wire going to the positive end of the power supply caps and resistors, and one of the other red wires is the center tap for the output transformer. So that's how that's all wired in, and the excess, of course, has been wired up. Now, when you install new transformers, there's always a kind of balancing act between tidying up the wires neatly and leaving enough behind so that if you have to work on those terminals again, you have enough excess wire and you're not trying to splice or stretch the wire as tight as a guitar string. So I've left a little extra of this blue and this red here going to the transformer in case these wires ever need to be worked on. So that's a deliberate little excess. They call that a service loop. Definitely want to leave a little extra when you wire in a new transformer. Don't cut them as short as you possibly can, especially because you could wind up accidentally soldering it to the wrong terminal, which I did a couple times on this project, but that wasn't covered in the video, so it didn't happen, right? Yes. So anyway, the original power supply layout of a 20 microfarad capacitor as the first stage, and then a 10K dropping resistor, and then a 10 microfarad cap for the second node of the power supply, and then another 10K, we can see it behind there, and then another 10 microfarad for the third node of the power supply. I've taken voltage measurements, and one of the interesting things is that at first oh wow, it's nice and warm. At first I tried this Russian 5Y3 in there. It's a Sovtech. What's the production code? 7th week of 2004, 0704. Okay. So this thing in the handy dandy TV7 tube tester tests well over 105 or so. So it's around testing around 105, at least on one side of it. If I reconfigure this to here, we can check the other side of the rectifier. So that side is also testing about 104. The minimum value on this tester for a 5Y3 is 46. And so like 100 and wow. I mean, it's just this Russian tube tests so much higher than, for example, this American GE. We can tell it's GE because of that type of etched lettering with the little braille-looking code on it. That is a GE manufactured tube, and that's an old stock 5Y3 out of a Hewlett-Packard test instrument. And it's a little soft on one side, you know, and it's testing around 60-something on one side and like 50-something on the other side. And then there's this Russian tube, which tests at 100 and something. So what's the practical difference? Well, in this amplifier, the practical difference is with this tube in, the main plate voltage of the 6V6s is running around 360 volts. With the Russian tube in there, the plate voltage is running closer to 390, almost 400 volts. And of course, the other voltages are different along the way. So that is probably a little much. And we're going to get into something that may or may not apply. I mean, this amplifier has a reproduction power transformer. And I wish I could unscrew this. It's a real pain to unscrew this thing because the speakers and the output transformer hardwired into the amp chassis as per the original design. So kind of popping it out and showing you what the output or the power transformer looks like is not so easy. It was slightly larger than the original. I had to drill 2 new holes. It was supposed to be a drop-in replacement. You know, Mercury said it was. I can't really fault them too much. Gibson at this time period, they would pretty much pick any component off a shelf and stuff it into an amp. So if they took a direct clone of a transformer from a Gibson GA-6 and made it, and it wasn't the same size as the one that was original to this particular amp, not entirely surprising. So they really can't be faulted for that. And you know, the replacement transformer was almost a 1/4 inch thicker in core thickness. So that should be a better transformer anyway, just for that, and it should run cooler and so on and so forth. But anyway, bottom line is, when you take a vintage amp, you have to account for 2 things. Number one, in the US, you know, we're used to 120 volts being the standard now. I measure my line voltage, it comes in around 120, 121, 122 sometimes, you know. Back in 1956, when this amplifier was made, 110 was really the standard, and a lot of line voltages were a little bit lower than that. So you have to consider that the original circuit was probably expecting to see slightly less line voltage, and it certainly probably wasn't expecting to see a Russian clone of a 5Y3, which, if you look at the plate structure and the cathode structure on that, looks absolutely nothing like a real 5Y3, right? And there's a 40-volt difference between these 2 tubes at the line voltage of 120 volts. So right off the bat, you have to consider 2 things when you take a vintage amplifier like this and you either repair or restore the original circuit, or you recreate the original circuit from scratch, which is essentially what we've done here. And one of the first things you have to consider is the value of these cathode biasing resistors. Now, I've got 2 100 ohm resistors in series, and they're biasing the pair of 6V6 output tubes. A lot of times in amps, you'll see 220, 250 ohm there. 200's a little hot. And you have to understand that, of course, line voltage was lower then, 10 volts lower, so 10% lower. So, and I think I failed to take that into account a little bit when I decided to stick to those 200 volt or 200 ohm resistance for the cathode. However, it's totally fine and within normal operating parameters when I have a kind of normal to weak American 5Y3 in there versus this Russian one. So, unfortunately, I've got tons of 5U4, tons of 5AR4. I've got a bunch of different rectifiers I could play around with in here, but I don't have another American 5Y3. For some reason, that's the only one I have, is the one that's in the amp right now. And it tests a little soft, but it's still well above minimum. Be interesting to see where a good new old stock American 5Y3 tests and what kind of voltage it gives me in this amp, right? Okay, so enough of all that. Let's power it on. I previously unplugged it because I was poking my fingers in there, so let's go ahead and stick the plug back in. Oh, before I turn it on, I want to get to this fuse holder. It's a little too tall. I've already ordered a new one. You can see it sticks above the top, so I've ordered a low profile one that will that will not stand proud at the top of the amplifier. That'll get replaced before this amp gets all buttoned up for good. But the whole reason the power transformer really had to be replaced in this amp was because, you know, the filter caps went bad because who knows how many things went wrong with the amp, right? And whoever owned this thing, their solution was to stick ever-increasing value fuses in there. When I took out that old fuse holder, it had a 3-amp fuse in it, and it was blown, right? So somebody kept pushing the values up there, and that's why the primary winding on the original transformer cooked. Don't do that. If your amp blows a fuse that's the correct rated fuse for your amp has a problem that needs to be serviced. Putting a greater value fuse in there is only going to increase the likelihood that you're going to have to replace something very expensive. Anyway, enough of the lecture. So let's turn it on. And one of the cool things was that the original little Tungsol number 47 light bulb for this amp was still in perfect condition. I looked at the filament under magnification and it didn't look like it had much wear on it at all. Okay, so it's just coming up now. Well, we've got some hum. Interestingly, when I crank up the gain, I'm getting very little hum compared to before. Huh. Something has changed. Are all the tubes lit up? I'm going to turn the light off for a second so I can make sure all the tubes are lit up and I'm even... Yeah, see, the 12AY7 isn't lit up. What's going on here? Okay. Now it's lighting up. Okay. So we need to clean the terminals for the filament either on this tube or on this socket. Oh, that's really weird. It was not doing that before. Why is it? Huh. That's really strange. That's really strange. So I think that's why we have no real amount of hum. It's because the first tube is not, the filament's not coming up. Why is that? I might have to go grab another tube. Maybe this tube's got a bad filament. mean, I don't think it's... Let's take a quick look. The light's glaring off of it. All the solder joints look horrible, but they're actually good. It's just the light's glaring off of it really bad. Huh. Interesting. Why? Well, I don't know what's going on there. So I'm going to have to pause this video and I'm going to have to check out what's going on with this tube. Alright, well, it's lit up now. There's something up with this socket. I can wiggle the tube around and get it to come in and out. I've already reheated the solder joints and the filaments, so it's not the solder joints. Yeah, we'll figure it out. That's definitely something I'm going to have to address before we button it all back up. But anyway, it's running now, so we can hear the hum I'm talking about. I'm going to turn up the instrument channel to 12 o'clock. It's not much. Now, that's all the way up. Seems like a lot, but the gain at this point is super, super, super high. And honestly, the original design with only 40 microfarads total of capacitance in the power supply, I'm going to expect a little bit of 120 cycle hum, especially at the extreme end of the gain. Having said that, I think a lot of that might be down to this 6SL7. And the reason I say that is because in this circuit, it serves as the phase splitter. And let's see, let's take a look at the schematic here. The way the phase splitter works on this is that it taps off of, so the signal's coming in here, both the signal from microphone input and instrument input are getting both sent through this half of the 6SL7, right? And you've got your plate resistors here and your 0.05 coupling cap, and then you've got this little divider network here, and it takes some of that off, some voltage off of that divider network, and drives the grid of the other half of the 6SL7, which is going to be out of phase. And so that's how the phase inverter works in this thing, right? So it stands to reason, and I actually tested the 6SL7. One half of this tube is significantly higher performing than the other. Huh, did you hear that? I guess we know right now that the amp, oh, let's hear how bad the amp picks up phone noise. Did you hear that? Anyway. Where was I? Oh, yes. So that's how the phase inverter works on this thing. And so any common mode rejection of hum from the power supply that you would hope to achieve in this circuit seems to me, please correct me in the comments if I'm wrong, but it seems to me like a good section to section match here along with this circuit. And I may need to look at the values in this circuit and take some measurements and seeing if it needs any tweaking. As we can see on the schematic, the number there is not readable. Now I think it's 6.8, and I think that's what I put in there. I'll have to go check that again. But anyway, whatever it was, I'm pretty sure I based it on the value of the old resistor that was actually in there. So that's that. So we have some hum at extreme, all the way up. Now, I played this thing earlier, and it's already screaming by the time you're here with this tiny amount of hum. And you're not hearing that hum over the signal at this setting. And the hum doesn't really get to be much until you get to right at the very end. Now, could be a couple of things we could do to address that. I think it's going to be down to tube selection more than anything. And I think that 6SL7 has a lot to do with it. The 12AY7 obviously has something to do with it. And we definitely need to suss out why the filament is going in and out on this. That's interesting. We get to that. But anyhow, that is pretty much the circuit completed. Now, let's have a look at the thing from the top. Here is the new strap. This is actually a Fender replacement part, believe it or not. The measurement of the strap and even down to the type of hardware was exactly the same as the original Gibson, which is interesting. The Gibson one may have had a raised hump in the middle. I'm not sure, but this is a very high quality leather strap. It works. The hardware that came with it was a direct screw-in replacement for the original one, which was riveted in. But these actual pieces themselves, these end hardware, whatever you want to call these buckles, they're really exactly like the originals. Surprising. For the microphone input, for now, at least, we have a black chicken head knob. I've got plenty of these. These older brown Bakelite ones of this particular thin profile are hard to find. This type is very easy to find. So maybe, scouring eBay one day, get lucky and find the correct chicken head knob for that. We're going to get to lowering this. Other than that, everything on the amp works great. Although one interesting thing is because the microphone input is purely capacitive coupled in this design, when you turn it way up, there's a little bit of a radio station. So you can hear it. Probably need headphones to hear that because the hum is so loud compared to the radio station. And again, you're never gonna turn that microphone input all the way up. I don't care how loud you play your harmonica. So that's it for now. What do we have for? It's funny. I've got a Ford Motor Company branded 6V6 pushing and pulling against a AC Delco branded one. I picked those two because they test the same and they're balanced. Those are probably not going to be the tubes that stay in this amp for good. So before we go, let's take a look, if we can, at the front of the amp. I'm going to pause the video while I turn everything around here. Well, here we go. Here's the front of the amp. The angle I have the light at really makes those little bulges in the cloth obvious, which they're really not when the light is hitting at a realistic angle. But that's the main light source we have to work here. So and then from the top, adjust the contrast. I'm very happy with the way this Fender leather handle turned out, and I mean it really does look like a perfect fit for this amp. And all we have to do now is put the back on, and a couple other things, like for example, they didn't take any consideration to the power cord. We don't want it banging up against either the rectifier or the output tubes here, right? So I need to anchor the power cord to the side of the amp somehow. That apparently was never done. I can't find a hole or any kind of thing that would suggest that they ever considered that, but that's something we'll definitely want to do before we put the whole thing together and call it a day. So there it is. The saga of the Gibson 6 is now done. I suppose I should play it, but I don't have a guitar. See, that's the thing. I'm a bass player. And I was playing my bass through this thing earlier, and it was actually pretty damn shredding, I have to say. But you'd want to hear a guitar through this thing. So maybe that'll be the follow-up video, is actually putting this thing in the hands of a guitar player and seeing what it sounds like.